stuff and some stuff that's fairly similar to what we've seen in the past. So we're going to create a table of values again. This time I'm not giving you the x values. Okay, so how do we figure out which x values you want to pick? Just do it. Charles, what's a number you'd want?
I want 0.
You want 0. I agree with you. I like the idea of 0.
Yeah.
Okay? Why do we like 0? Because it's a y-intercept. Why do we like 0? No? 0 is the hero. 0 gives us a y-intercept. Steven, what else do you want? 3. Okay? I'm going to pick the number 3. Why did you choose 3? If I plug 3, let's do 0 first. So if I plug in 0, we're going to find our y-intercept, right? So this part is going to cancel out, and so we can figure out our y-intercept is 2. Okay, cool. So there's a y-intercept. If I use 3, okay, so we'll go back to that piece. My computer's brain is so overloaded right now. I know. Okay, so if we plug in 3, we're going to end up with -9, and this 5y, so I'll end up with 19. Is 19 divisible by 5? No, so we're going to get kind of an ugly fraction, and that makes it difficult to kind of graph, right? Let's see if we can figure out numbers that would be friendly, right? Like something that would be nice. If I put this into our slope-intercept form, so I'm going to add over the 3x plus 10. And then I'm going to divide by that 5, so we'll end up with our y equals 3/5 x plus 2. Okay. What would be good increments to go up or down by for x that would give us nice numbers? What do you think, Eric? That's okay. This is brand new material. What's your guess? Based on that slope we just found, what would be a good increment for x? So I get nice numbers. Five. Why? Why do we like 5?
Because the denominator is 5.
Good. The denominator is 5, so everything I put in here is essentially going to get divided by 5. And so if I have things that are multiples of 5, it'll keep numbers very nice for us. So we can go with 5. Okay. And then we like to have some negatives involved so you can see what's going on both sides of your y-intercept. And so if I plug in 5, 5 in here turns into 3 plus 2, which is 5. If I put in a -5, it turns into a -3 plus 2, which is -1. Okay, this is going up by 3 in my y values every time, which is to be expected since we're going up by 5s in my run here, my x's. My rise should be my 3s. That's good. So what's my last number? What do we want to pick? Danielle, what do you want to go with? 10. 10. I like that pick. Okay, so we're still going up in increments of 5s. And so when we plug that in, we'll see that we end up with 6 plus 2, which is 8. Okay, and now we have a nice table that's got very nice points for us, and then we can sketch the graph. Okay, so from here, we go to sketch this graph. You've got your y-intercept at 2, -5, -1, 5, 5, and 10, 8. Okay, so we start to see we have a rough sketch like this. When we're doing straight lines, it'll be, I'm going to want you to at least get your y-intercepts. And we already have these coordinate points already kind of labeled. But anytime we do a sketch in this class, I'm going to want you to at least get your y-intercept. Most of the time, I'm going to also ask you for your x-intercepts. A couple of the problems tonight, the x-intercepts are kind of ugly, and it's not super important since we're just doing straight lines. So I'll let you just use other points. But straight lines, usually we only need, oops, this is supposed to be 10. We only need 2 points, right? Because any straight lines are 2 points. Oh my gosh, this screen casting makes everything else so slow. Okay, so this would be an acceptable sketch. Okay, it doesn't necessarily need to have perfect straight lines. Okay, it doesn't even need to have axes really labeled, but depending on how perfectionist you kind of are, feel free to make it more or less neat. Okay, as long as you've got points identified that are in the key locations, that way I can kind of make sure you have the idea going on and it'll give us a rough shape. Okay, so that would be a way for us to do that. See if I can make this move without freaking out the computer. Okay, next type of thing we're going to see is, come on, it's thinking so hard. There we go. Okay, next thing we're going to take a look at is graphing these equations in intercept form. And so if we can get our x and y intercepts, that'll make things graph, especially linear functions, will make things graph really easily. And so degree of 1 for both x and y is going to tell us we have this linear function. So it should be a straight line. How do we find the x and y intercepts again? Jesse? Good. So when x is 0, our y-intercept is 12. Good. So I'm going to plot that point. So we'll have this coordinate point of 0, 12. That was a 2. Okay. If I plug in a 0 for y, my x is -6. So we'll have this coordinate point over there. We've got -6, 0. So now I've got 2 coordinate points, and I'm able to draw a straight line. They also want us to plot a third point, just as a check. So how can I plot a third point? Sydney, what would you like?
I have no idea. I can't see the board.
Okay, I'm blocking you the whole time. Perfect. Okay, so looking at it now, how can I get a third point? How do I get any points on the line?
Sorry.
I can pick anything I want, right? Right? To find a coordinate point, I just pick an x, find an input, find an output off of it. What number do you like?
Let's go with 3.
3. Okay? So if I plug in 3 for x, I'm going to get -6, so we'll add that over. So then y is going to equal 18. So we'll have this last piece that is a coordinate point of 3, 18. Okay? So for that third point, really all you need to do is find any point you want. And so find some input, and then we get this stuff. And then go ahead and draw your hopefully straight line, which mine is a little bit less than straight because I'm trying to draw from the side here. Okay? And we'll have our sketch. We okay with graphing stuff? Okay. Okay. And next piece we're going to see, hopefully. Come on, sweet, there we go. Okay, compute the slope of the line with the given points, and then we're going to use that to find 2 additional points and help us sketch the shape. Okay, so how do we find slope? Do we remember that piece? Yes, Swetha. Okay, so we've got that idea of it's got to be this y2 minus y1 over the x2 minus x1. Guys, so there's that formula thing that's been pounded in our head over and over and over. Oops, this isn't x, this is m. Anybody know why m stands for slope? Or how does it help you remember? Y equals mx plus b, and m is always our slope. Does anybody know where that came from, though? I've been told there's a French word that stands for slope that starts with an M, which I think is where it actually came from. But I had a crazy wild junior high teacher that was like, here's the way you remember that M stands for slope. It's the mighty slope. I was like, really? Okay, sweet. So it stuck in my head, like, since I was in 7th grade, for slope. Anyways, let's take a look at this. So based on that formula that we've been regurgitating all the time, I've got, regurgitating, we don't like that word? No, ew. Okay. So we got the difference between 3 to 8 and negative 2 to 5. Okay, is that the same as saying or the same? That's supposed to be a 2. Okay, or okay. So let's call this option A, option B, option C. Which of those is correct? There could be multiple answers. Which of those is correct? Talk inside your group. Do we like A, B, C, or some combo of multiple? All in favor of A? Okay, so there's A for our slope. There's B for our slope. There's C for our slope. Which ones do we like? All in favor of A? Okay, there's a couple hands for A. We're thinking maybe. Okay, all in favor for B? Nobody on board for B. All in favor of C? Lots of us on C. Why do we like C? Because it's right. How is it right? Because as I read right to left, we think of this as coordinate point 1 and this is coordinate point 2. So using our formula, we say I've got my second coordinate point there. I've got my first coordinate point here. Okay? So that one's by the book, basically, right? Why don't we like B? Charles?
Oh, I would.
Why don't we like B?
Because it makes up for the coordinate.
It mixes up our order, right? So this one's getting crisscrossed, and we don't like that. Okay? Alex and Nathan, how come you guys liked A?
I was just raising my hand with him to make him feel better. I knew it was eight.
Okay? Alex gives me the same answer. What do you mean?
I mean, it's -5, -3.
It's the same thing, right? Who's to tell me what's my first coordinate point and what's my second coordinate point? I could be looking on a graph somewhere. Doesn't matter which order. As long as you keep these stacked over the top of each other, you're in good shape. As soon as we get crisscrossed, that's where things will become messed up and you won't get the right answer. But as far as the order of the pairs, it doesn't necessarily matter which one you deem to be coordinate point 2 and which one's coordinate point 1. Okay, so that's kind of the important piece there. So let's go ahead and actually find our slope now. So finding our slope from here, we end up with 5/7. Okay, so there's our slope of 5/7. I can write the equation to a line now because I have slope. Which format do you guys like putting your lines in?
Say again?
I want to build a line. What's the way you guys like to do that?
Rise up, raise.
Y equals mx plus b. That's our favorite. Okay. So if I'm working,
Look at Mr. Adams' class. Yeah, I don't know. That would have been Mr. Adams.
what is going on right now?
We're talking about slope. It's like
Okay. So if I want it, y just work.
X and Y walk. That's another one. That was K's song.
Okay. So if we want it in the form y equals mx plus b, my m is this 5/7. What is my b value? Huh? It's the y-intercept. How do I find b?
You actually plug in numbers.
Good. Let's plug in a point. I like that. Okay. Which point do you guys want to plug in? Paige, where do you want to go? Okay, so if we plug in the 5 and 8, my y value is 8. Okay. My x value is 5. I can then go solve for my b. When I do that, we're going to get into sevenths here, so this will be 56 sevenths. This will be 25/7. I can subtract 25/7 from both sides, and b is going to equal 31/7. Okay. And so based on that information, now we can go back and actually build our equation. So the full equation we would use here would be y equals m, which was our 5/7, x plus b, where b is now 31/7. Okay, so there's the equation to our line. Looking good. Last piece it wants us to do is make a sketch of this graph. Okay, so as we go to build this sketch, we're going to work on this side for a bit, see if that helps. Okay. Except for my handwriting will be so much worse from this side. Try to write left-handed. Okay. So when I go to sketch this, we've got a couple of points, right? There's a couple given to us. We've got -2, 3. Let's call that -2, 3. We've got 5, 8. So 5, 8. And then we also have one other point. What did we find? We found the y-intercept. So that's at 31/7, which is roughly 4 point something. So that happens to be right there. How can I find one more point? Using slope. Think about using the slope. How can I find one more point? Nicole, what would you do? Excellent. So which coordinate point do you want to start at? And you go find a new one. Yeah. Okay, so if I start at 5, 8 and I use my slope, going up 5 is going to put me 2. Going up 5 is going to put me where? I start at 8. I'm going up 5, so we're going to be up 13. And then my run is 7, so we were at 5, we're going to go to 12. Okay, so you can use your slope to go find another coordinate point, and now we've got that extra point. Sketching our line. We're in good shape there. Okay? Super awesome sketch, right? Okay. Are we feeling okay with that? All right, we got one more thing to look at. Close. My computer's
Well, that's just me. I didn't see it.
Okay. Very nice, guys. A doodle at you. Cool. Let's throw that doodle away. Sorry, this computer works so slow while it's screencasting. Okay. All right, last question we're going to look at is a lifelike problem. And put this whole problem actually in the picture. There we go. Okay, so we're going to look at a graph that models this situation, okay? So the relationship is the volume of garbage going to the dump based on the number of trucks that show up to the garbage dump. Okay? So here's that model. Our two goals we're going to work on here is to determine what the slope is of this line, and then what does the slope represent in this situation. So going beyond just, oh, it's rise over run. We got to think about what does it actually mean in this situation. And then we're going to figure out or estimate how many garbage trucks will show up if we're dumping 1,000 cubic meters. Okay, so how do we find the slope first of all? Rise over run. So if I'm looking here, I know we gotta say it. So if I've got my rise over run, I'm gonna go from 360 up to 960. So our rise is 600. Our run is gonna go from 30 over to 80. So our run is 50. So our slope in this situation is 12. What does 12 mean to me, Spencer? Okay, let's try to guess. In this specific situation where we're talking about volume of cubic meters garbage dumped, number of trucks coming into my site, what does 12 tell me? That's how many trucks took to do what? So it took me 50 trucks to dump 600 cubic meters. So what does 12 tell me? Check in with your table group real quick. See what they got. Matt, what do you think? What does 12 mean? Excellent. So my rise, or my Y values, is the volume of garbage dump. So every single truck is going to dump 12 cubic meters. Is roughly what we're hearing here, right? So now we can use that to build our equation of the line. Y is going to equal our mx plus b again. So y equals 12x. What's my b this time? And what's my y-intercept? 0. Does that make sense? If 0 trucks show up to the dump, how much garbage will get dumped? 0. So we actually go through the origin on this one. So our equation is going to just be y equals 12x because our y-intercept is 0, so the plus 0 idea. Guys, so then the last piece of this question asks you, how many trucks will it take to dump 1,000 cubic meters of garbage? What does the 1,000 cubic meters represent? What variable is representing the amount of trash? It's in cubic meters, that's our unit, but what variable am I using to represent that? We look at our coordinates. Our x is trucks, our y is garbage. So 1,000 cubic meters should go in the y. So we can substitute that in. We get 1,000 cubic meters dumped, where 12 cubic meters per truck is what we can handle. We can divide both sides by 12, and we'll see it's like 83.3 or something like that.
Yeah.
And so roughly takes us 84 trucks to dump 1,000 cubic meters of garbage in a day. That's about how many people will go there. Okay? Sound good? All right, so that's what we got today.